Hello everyone, my name is Dr. Ramesh Kumar Gajula, working as a assistant professor in the Department of Chemistry, Vardhaman College of Engineering. In this session, I am going to discussing about the synthesis of polymers. In the previous session, already I discussed the synthesis of polymers can be classified into two types. They are addition polymerization and condensation polymerization. So here, now I am going to discussing about how we are going to synthesize the polymers by using the first process, that is addition polymerization process. So here addition polymerization means the process in which the monomers are simply combining together. It gives the product of polymer without elimination of any byproducts is called addition polymerization process. During this addition polymerization, the monomers are involving. Which monomers are having the multiple bonds? Only the type of monomers are going to combining together. It gives polymer product. Now here we can see the example of, here I am taking n moles of ethylene monomer molecule. It gives polyethylene polymer. So here the ethylene monomer is having the double bonds. Here one more example. This is the vinyl chloride. So vinyl chloride is undergoing polymerization. The process of addition polymerization, it gives polyvinyl chloride. So here in these both cases, here the monomers are having double bonds. If for example, if I are going to here I am going to taking the acetylene molecule, n moles of acetylene molecule is undergoing polymerization. It gives polyacetylene polymer. So here acetylene is also having the multiple bonds. Mean during the addition polymerization, always the monomers are having double bonds or triple bonds, then they give the addition polymers. So the monomers are going to having, these are the following characteristics during the addition polymerization process. Now the first one, the functionality of the monomer is double bond. And so here the monomer is having the double bond, then it is considered as a bifunctional monomer molecule. Now the polymerization is take place by self addition of the monomers to molecules to each other through a chain reaction. So that's why addition polymerization is also known as chain growth polymerization process. During this addition polymerization, there is no formation of byproducts like ammonia, water, or any other byproducts are not forming in case of addition polymerization process. Now the polymer has the same composition of the top monomer. Now here we can see in this previous slide. Now here we can see the monomer is having CH2 double bond CH2. Now the composition of polymer is also having CH2 and CH2. So always the composition of polymer is exactly equal to the monomer composition. That means there is no changes in the composition of the polymer molecule. And next one, the molecular weight of the polymer is the exactly equal to multiple of the monomer molecule. Next, here the mechanism is going to carried out in three steps. They are chain initiation, chain propagation, and chain termination process. Always the addition polymerization is going to carried out in three-step mechanism. They are chain initiation, propagation, and termination process. Next one, here in case of addition polymerization, here the monomers are contain either double bonds or triple bonds. Here what happened? The double bond going to converting into single bond formation here. So at that time, then the amount of energy is going to liberated, almost it is 20 kilocalories per mole of energy is going to evaluated during this addition polymerization. So hence this reaction is exothermic reaction, and the addition reaction mechanism is very fast reaction. And in case of addition polymerization, we need some initiators. They are going to start this addition polymerization mechanism process. Now here I am taking some examples like for addition polymerization, some olefins like ethylene molecule or propane. If you are taking the ethylene, then it is undergoing polymerization, it gives polyethylene molecule. If you are taking the propene as a monomer, then propene is undergoing polymerization, it gives polypropene molecule. Now some other examples of vinyl compounds. So here I am taking one example for vinyl compound, that is vinyl chloride. Vinyl chloride is undergoing addition polymerization, it gives polyvinyl chloride polymer, and this is the vinyl benzene known as styrene. Then it is undergoing addition polymerization, it gives polystyrene polymer. And some of the allyl compounds are also involving in the addition polymerization. This is the allyl chloride, and sometimes the dyes are also going to involving in addition polymerization. So this is the example for 1,3-butadiene. And next one, moving to condensation polymerization, also known as step growth polymerization process. Already I discussed the definition of condensation polymers. Here the process in which the polymers are formed by the combining of monomers with the loss of or with elimination of some products like water molecule or ammonia or methanol. This type of byproducts are going to forming during this condensation polymerization. Actually, in case of condensation polymerization, the monomers must and should contain the functional groups. So which monomers are having the functional group? So that type of monomers are going to involving in during the condensation polymerization. In case of addition polymerization, the monomers contain either double bonds or triple bonds. But here in case of condensation polymerization, the monomers contain the functional groups. Either acidic functional group or basic functional groups are going to involving in the condensation polymerization process. Now these are the characteristics of the condensation polymerization. Now here we can see the monomers contain the functional group like either OH, carboxylic acid, either basic functional group amines, then esters functional group, and sometimes maybe is having halides functional groups also. Now here in case of the functionality of the monomer is more than 2 or 2. So the monomers must be either dibasic acid or diamines or maybe triols. Monomers contain either alcoholic functional group in case of condensation polymerization. Now here the polymers are going to forming step by step in case of condensation polymerization. So that's why this polymerization also known as step growth polymerization. Now here during this polymerization process, as already we discussed, the formation of byproducts are take place in case of condensation polymerization. They are either HCl or maybe ammonia, or sometimes maybe form the water molecule or methyl alcohols are going to forming. Next one, the reactions are not exothermic in case of step growth polymerization or condensation polymerization process. Next one, the molecular weight of the polymer is not exact multiple of the monomer in case of condensation polymerization. But in case of addition polymerization, the molecular weight of the polymer is exactly equal to multiple of the monomer, because there is no formation of byproduct in case of addition polymerization. But here in case of condensation polymerization, along with polymer products, some byproduct will also form. So by the forming of byproducts, then what happened? The molecular weight of the polymer is going to decreases. So that's why here the molecular weight of the polymer is not exactly equal to multiple of the monomer. Next, it does not follow the any 3 steps mechanism like initiation, propagation and termination process. And next one, these reactions are catalyzed by catalyst. We need some catalyst during this condensation polymerization process. Now here I am giving one example, the polymerization of a diacid along with diols, alcoholic functional group, both are reacting together, it gives polyester product. Okay, so for example here I am taking terephthalic acid is reacting with ethylene glycol, we are going to getting the polyester or polyethylene terephthalate polymer is going to forming in case of when the diacids are reacting with diol compound. And here one more example, that is nylon 6,6. Nylon 6,6 polymer is going to forming the reaction between hexamethylene diamine and adipic acid. Both are reacting together. So n moles of hexamethylene diamine and n moles of adipic acid is reacting with hexamethylene diamine. It gives nylon 6,6 polymer through the condensation polymerization process. Next, moving to differences between addition and condensation polymerization process. So the first point, in case of addition polymerization, it is formed by the addition reaction between the monomer units. But in case of condensation polymerization, the condensation polymers are formed by the elimination of small molecules. When monomers are reacting together, it gives byproducts is known as condensation polymerization process. And next one, in case of addition polymerization, the molecular weight of the polymer is not equal to the multiple of the monomer, but in case of condensation polymerization, the molecular weight of the polymer is not equal to multiple of the monomer. And next, third point, the addition polymerization is going to involving only one monomeric unit, but in case of condensation polymerization, we need more than one monomers are required. Minimum here what happened, the minimum 2 or more than 2 monomer units are going to involving in case of condensation polymerization. Now in case of addition polymerization, the monomers are having double bonds or triple bond. That means the monomers are considered as a unsaturated molecules are going to involving during the formation of addition polymerization process. Now in case of condensation polymers, here the monomers are contain must and should functional group, either acids or basic functional groups or maybe alcohol functional groups are going to involving in case of condensation polymerization. Now addition polymerization also known as chain growth polymerization, and in case of condensation polymerization is known as step growth polymerization process. Next one, so addition polymerization reactions are highly exothermic reaction, but condensation polymers are not exothermic. Here we need some amount of energy is required to start the reaction, so that's why condensation polymerization reactions are endothermic reactions. The next one, the mechanism is going to carried out in 3 steps. They are chain initiation, propagation and termination process in case of addition polymerization process. But in case of condensation polymerization, there is no mechanism, there is no involvement of 3-step mechanism like initiation, propagation and termination. Next, here the initiator is required to start the addition polymerization reaction, but in case of condensation polymerization we need catalyst. Now here the functionality of the monomer is bifunctional, but in case of condensation polymerization either bifunctional or trifunctional monomers are required in case of condensation polymerization process. Now compared with condensation polymerization, the addition polymerization is very fast reaction and it is the slow step reaction, condensation polymerization. Now the examples of addition polymerizations are polyethylene, PVC, Teflon, polystyrene. These are the some of the examples for addition polymerization. And nylon 6,6, nylon 6,10, bakelite and polyethylene terephthalate. These are the some of the examples for condensation polymerization process. Okay, with this I am going to concluding this session. So in this session we have covered the synthesis of polymers by using addition polymerization and condensation polymerization process. Along with we have covered the differences between addition and condensation polymerization process. Thank you.